So hi everyone, I'm Matteo Carlini, Director of Software Technology Management at ARM, and I have the privilege and the pleasure, together with Shabu, my colleague here, to be also the chairman of the board for the Trusted Firmware.org project. So as usual, as tradition, we are going to give an update on what's happening on the community project on the Trusted Firmware side. So here is the agenda, and here is a lovely picture we take last 6 months ago at Last Connect. Bad news first, we don't have cake today, so if you want a cake, just go out. We usually run some little celebrations, but we are reserving that for some of the next time, and Shabu will tell you when, at the end. So the agenda is pretty simple: community project update, Trusted Firmware A update, that's my part, and then I'm going to hand over to Shabu for the TFM part and some hints on how to get involved in the project. So what is Trusted Firmware as a community project? So Trusted Firmware as a community project is all about collaboration. So it's a platform that allows partners to collaborate on the secure software code base. So the code base is open source, obviously, otherwise it wouldn't be an open community project. It's always been open source since 2013, and it's delivered with an open source permissive license. So it's a BSD-like license, so it's a free closed standard license. Without contribution license agreement, you don't have to sign anything. Any individual can just post patches and contributing under the terms of the DCO. So it's completely open. It's open governance. What does it mean? It means that there is a board of project members and a technical steering committee that oversees and discuss and decide about the strategic and technical direction of the project. There is an OpenCI system, so every partner has the chance to put their board on the OpenCI, and Shabu will describe a bit more how does that work. And it's effectively a collaborative platform with mailing list, public conversations, public forums in which we discuss all together the challenges and the strategic direction for the security issues that you find in your firmware. And that's effectively what it is. So a place in which security challenges are discussed and solved in a unique manner for all your products in which you deploy Trusted Firmware. So a bit of history, now a bit condensed because it's becoming quite a long history. So I usually present a more detailed snapshot, but this time I just decided let's keep it short. So we've got beginning of the story in October 2013 when Trusted Firmware, well, the formerly known ARM Trusted Firmware, was open source on GitHub. 5 years of history and success up to March 2018, in which ARM, given the success of ARM Trusted Firmware ATF, decided to basically create a sibling project for the microcontrollers, for the M-class processors. So we decided to also change the name a bit. So the former ARM Trusted Firmware is now Trusted Firmware A, TFA, that's, as the name says, is for the A-class processors, and Trusted Firmware M for all the microcontrollers. 6 months after, it was already cooking in between, the beginning of the project, of the community project. So ARM and other company members decided to put together their effort and kicking off the TrustedFirmware.org open governance community project. So it's about a year in the project for now. It's been a huge success up to now. We'll see some data in a bit. Today, we are there. So a couple of weeks ago, we were part of the open source firmware conference in the Bay Area. If any one of you was there, you might remember, we were there. And today, a good news that you might recognize that symbol. The good news that we announced yesterday in a PR from Linaro is that we welcome also OPT as part of TrustedFirmware.org. So Linaro has decided to donate OPT, so OPT will be part of the Trusted Firmware family now, if you want, because it's not only going to be the runtime EL3 firmware as you know it on the application processor, but it will also embrace all the secure software and secure services on top with a reference implementation for them. So let's have a deep look. So that's now the new shape of TrustedFirmware.org as a community project. TFA, OPT, TFM. this gives us the possibility to have a comprehensive set of secure firmware and secure services as a reference implementation in the trust zone software area. And this is a reference, so it's an example that can be easily ported into many other trusted software implementations, so like commercial trusted implementations. A snapshot of the current members. So you will see that there are very different companies coming from very different market segments. So ARM, Linaro, Google, TI, ST, Cypress, and Data.io are all part of this roundtable of discussion, and they are helping putting their brains and their energy in, they're helping in defining the strategic and technical direction of the project. And as I said, there are very different companies coming from very different market segments, because trusted firmware, now with TFM, TFA, and even the inclusion of OPT, is really cross-market segment, addressing all possible segments from end-user devices, so wearables, IoT, the obvious mobile smartphone market, also the new emerging automotive market segment with all the initiatives that are going on recently, laptops, clamshells, edge devices, embedded, down into the more traditional general purpose servers, and even into the cloud. So every segment has its own port and its own reason for adopting trusted firmware on the A class or on the M class, and now also adopting OPT as part of their reference implementation. So Shebu is going to tell you a bit more afterwards how to get involved and be proactive in this project. Now I'm going to focus a bit on the specific Trusted Firmware A pieces. So what's going on the TFA side? What happened in the past 6 months, and which are the plans for the next 6 months up to Next Connect? So first of all, a good news. So last time we usually present a snapshot on the ratio of the commits. So how many commits are coming from ARM? How many commits are coming from partners? So now we reached the point up to June in which it's basically half and half. So half of the contributions are coming from partners. Now, I haven't had the chance to count just July and August. I'll do that for the next NR Connect, but I could be surprised. I could see that ratio moving more towards partners' contribution. You should see there is a trend, right? So starting from 2017, the increase of partner contribution is dramatic. So it went up more than 600 with respect to the past. We've got 30 partner platforms supported upstream, not counting ARM platforms. We have more than 16 different vendors that are contributing their platform ports upstream. Again, not counting ARM platforms. This is only community effort, partners boards. So Trusted Firmware A is now at the version 2.1. There will be a version 2.2 coming out in October. We are still keeping our 6 months release cycle, every 6 months a release. In this case, it's not a major release. We are not going to change up to 3.x. We are still staying on version 2. There is no major change in ABIs. This is a highlight of changes that will come out in the 2.2 version. So you will see there are a bunch of architectural features that have been developed on the TFA side. So pointer authentication was already enabled for the normal world to make use of it, so Linux kernel and so on. Now we enable that in the secure world as well. So for using that at EL3 and even on a trusted OS side, so lower exception levels in the secure world. We enable BTI, so branch target identifier, both from the normal world and for the secure world to use it. We enable memory tagging for normal world to use it. Again, Linux kernel, Android ecosystem, and the like. Updates on the GeekV3 driver, updates on RSA keys, FreeK key will now be supported, and few updates on ARM platforms coming out. There are a bunch of also new partner platforms. I usually do not list partner platforms in these slides, but it's all available upstream. I'm only mentioning here the ARM-based Cortex and Neoverse cores and platforms. Timeline, mid-October. You should see the tag coming out. There will be articles, as usual, on trustedfirmware.org, on the blog post. and we will make the usual noise about the release. Yep. Okay, so what we are working right now. So we are still working on enabling memory tagging as well for use at EL3. It's a bit tricky. There is no dynamic memory allocation at EL3, but there are still use cases in which it could be useful. There are a bunch of platform security requirements which we have been working on for a while now. And there are complex topics that we are addressing also with the ecosystem. So we are in touch with Linaro, the Ledge working group, and others to implement attestation and measure boot, so providing reference implementation for a firmware TPM, and how TFA and the early bootloader stages take measurements and record these measurements into a TPM module. Multiple signing domains, separate chain of trust, how different vendors could sign bootloader stages and coexist into the bootloader images without being dependent on one another. Secure firmware update, self-explaining. We want to provide a reference way for the secure word firmware to act on whatever firmware blob comes from the normal word, from a capsule update or for whatever medium, but at some point the secure firmware will need to take care of firmware update. We are also working on a new build environment because the old one was really no more fitting the purpose. There is a new documentation system, so documentation has now been rendered by a read the docs website, so layout, so the link is there. OpenCI, we are about to deploy, also on TFA, as it is already working on TFM, a continuous build of all the open source upstream platforms and continuous testings. Initially on Juno, based on a Lava board farm that Linaro is hosting, and eventually in the future, continuous testing on FVPs, as well as partner boards. So members of the project can decide to donate or work on with Linaro to enable continuous testing against their remote lab, for example. So no presentation around TFA would be good if I'm not going to talk about the SPM, the Secure Partition Manager. So the Secure Partition Manager has been our friend for quite a while now, a couple of years, probably more. So where we are today. So I would like to spend a bit of, 5 minutes, still have time, to talk through which were the initial challenges that we were trying to solve, where we are today, and where we are going with the SPM implementation. So this is a typical picture that we see deployed. This is a case in which a trusted OS is used. So you will see that, in general, the blue boxes are the boxes that comes from trustedfirmware.org. The red boxes are boxes that comes from either silicon vendors, OEM, ODMs. So they are traditionally not part of the generic upstream firmware. This is the normal world kernel hypervisor and secure world trusted OS in green with applications. So it's a complicated picture, but the thing that scares us the most is that the EL3 part is particularly complex. So EL3, over time, embraced different pieces of firmware that were meant to be implementing platform services, secure services, that in theory could be moved elsewhere. The problem is, up to now, there was no software architecture for allowing these services to be moved elsewhere. So the case without the trusted OS, it's not much different, actually. So it looks more or less like this. Again, another bunch of secure services at EL3 running in the runtime firmware, so BL31 for those who are familiar with the bootloader stages. Which are those services? These services can be very different depending on the segment. It can be DRM services, it can be secure payment services for mobile, or more traditionally on edge or server, secure storage, crypto services, as well as some more traditional platform services like how to do secure boot and trusted board boot from the very early bootloader stages, power management, specific differentiator services from the silicon vendors, and things like errata or RAS handling, for example. So all this stuff were traditionally put at EL3. But that's not the direction we would like to see for the EL3 firmware. So we dream about a world in which EL3 firmware is generic. It's standard. It comes from trustedfirmware.org, and we really dream about a world in which you can point the firmware running on your device to a specific firmware version on trustedfirmware.org. You can say, oh yes, my smartphone is running version 3.x of trusted firmware, and I know it, and that's standard. So how to achieve that? Still having the way of preserving the needed platform services and security services. So there are different things that needs to happen in order to arrive to that point, and we are working into that direction. Just as a side note, we already have these green boxes here, a way for configuring the firmware, so a unique firmware image with some configuration files, so to take into account different variations of configuration parameters, like how many secure memory do I have in my system, or where are the base addresses for jumping into the secure world. So these kind of things can be configured already today dynamically. You don't have to recompile your firmware for making these changes. You can keep a unique firmware blob and configuring these parameters through a configuration file. It is an XML-based, actually it's based on device tree. We are working towards the standardization of device tree with the Linaro project as well. So if this is the direction to go, where are we today and what are we working on? So traditionally, this is where we are today as an upstream reference implementation. So we introduced these concepts of secure partition and secure partition manager. So we did that now almost 2 years ago with our architects. So the concepts are basically isolated execution environments running in the secure world, today only at SEL0, that can execute services that have a limited view of the system resources, and ideally those services are isolated one another. Now, in this picture, there is just one service, because this picture is based on the existing specification, the communicate spec, that relies on the management mode defined on the UEFI PI spec. That's what we've got today. Everything is implemented at EL3 in terms of a partition manager that dispatches the request coming from the normal world through this common channel and dispatches it through a little shim into the partition running at SEL0. So this works. There are already platform ports available upstream, like the SocialNet platforms and others that implements this model. We've got our Armv8s that demonstrate this model as well. So what's the problem? Well, this model has few problems. The first problem is that you can run only one single partition. There is no way, from the specification point of view, to allow for multiple calls of multiple services into the secure world. First problem. Second problem, this is a run to completion model. So you fire the request and your Linux kernel wait for the answer. This doesn't really scale in most of the cases. So we want a model in which the Linux kernel or the normal world operating system, whatever it is in control of the cycles that its CPUs are using, basically. So in order to take into account all these things, our architects are working on the specification side, and we are working on the open source software implementation side. So the specification side is called Secure Partition Client Interface. It's currently in beta. It's available for all the ARM partners. It will be released publicly more or less by Christmas times. That's what we have been promised by our architects. And we, in terms of open source software reference implementation, we are going to provide a model that is a two-step model. So the first step is, what can I do if my platform is an 8.0 or an 8.2 ARM platform? So it doesn't come with SEL2. There is no SEL2 available here because I have not an 8.4 platform. Okay, so in this case, the picture that we're trying to build together with Linaro, the security working team, and also working with Ledge that is trying to prototype this work as well, is having a reference into a trusted OS, SEL1, and this is where OPT migrating into trustedfirmware.org fits quite nicely. So having a reference implementation that has a little partition manager here that dispatch on his own the request between traditional trusted applications and standalone services that will execute, again, those secure services or platform services that you need for your platform. Now, just to increase, again, the value that we are going to deploy through trustedfirmware.org, the trusted applications are meant also to deploy some reference implementation of services themselves. So services like attestation, crypto operation, and so on, that are part of the broader ARM PSA story, Platform Security Architecture. So all the blue boxes will be delivered and developed in open within the scope of the community project, trustedfirmware.org. Obviously, our partners could change their own trusted OS of choice and pour the changes in their trusted OS of choice. But our goal is really to provide the reference, especially from an EL3 upwards. EL3 is particularly important to us because it's the highest privilege exception level in the system. So if your EL3 firmware is compromised, you basically lose your system. So EL3 should be as generic, as standard, as certifiable as possible. So with this move, we are hoping that our partners will be encouraged to move their services up to lower exception levels, so also providing an easy way for going into certification and security audit of their EL3 firmware. Because that's really the important thing that we care about, that your devices are secure. And in order to be secure, you need to know, everybody needs to know what is running at EL3 and that is stable, certified, and security audited. Final step, if you're going to have an 8.4 system with SEL2, here is what happens. And if you see the previous slide against this one, so the transition, if you implemented in your trusted OS of choice or in OPT the SPCI interface, the transition will be relatively straightforward because the trusted OS will maintain the very same interface. The applications running here, so the services running at SEL1, will keep the very same interface, SPCI. We will just inject the SEL2 SPM, Secure Partition Manager, in the middle that will allow our partners to decide. Sorry, just realized that the layout got messed up a bit. That's probably Chrome. So the SEL2 will allow our partners to decide what to run in the secure world. So this picture doesn't mean that you need to have a trusted OS by any means. So SEL2 will just allow our partners to decide where to run their services. If they want to run their services in isolated SEL1 partition, they could do that. They could have multiple SEL1 partitions. There might be no trusted OS at all. If instead you want to run a trusted OS, you will have the possibility to run one trusted OS with your favorite trusted applications on top, or multiple trusted OSs with different SEL1 running different trusted applications, each one with their own scope, implementation, and specific technicalities. So this really achieves kind of multi-tenancy as we see it in the secure world under the strict control of the SEL2 firmware that decide which resources each of these partitions is allowed to see. And these resources will be protected by the hardware, so they will not be able to interact badly with the memory of the other partition. So one partition will not be able to corrupt the memory space of the other partition. That is where you really achieve complete full system-wide isolation, obviously coupled with the other system IPs that ARM is going to produce, SMMU and GIC. System-wide isolation across your entire system. So that's the direction we are going with trustedfirmware.org. Now, timelines. Take it with some warnings, as usual. I'm the product manager, but roadmaps are usually tricky, so rough timelines. We are here today, that's what's available upstream, SEL0, MM-based, standalone partitions. We are working on some initial services, so resource description, multiple signing domains are all prerequisite for achieving the further steps and measure boot. We are hoping by early 2020 to provide and consolidate the implementation of OPT with SPCI running standalone secure partition and some PSA trusted applications that enable secure services. Plus, also we would like to work on secure firmware update reference, early 2020. A bit later, second half of 2020, we will introduce the 8.4 extension and the Secure EL2 virtualization extension with the SPM moved at SEL2 based on SPCI. So that's all from my side. I will keep answer at the end, and I'm handing over to Shabu for the TFM updates.
Thanks, Matteo. So I'm going to talk a bit about the Trusted Firmware-M projects that's part of the biggest trustedfirmware.org project. So to give some context, so to me, Trusted Firmware-M is this very fast-growing toddler now at San Diego. We started our journey back in the Hong Kong Connect when the project was launched. It was a baby at that point. When we reached Vancouver, it was an infant. We celebrated its first birthday at Bangkok with some cake and wine. And now I think it's going through that excitement of being a toddler with a lot of toys and friends, whether it's PSA certified, an open CI system, a lot of boards to play with, and a lot of operating system friends as well. So I want to talk a bit about what are these toys and how they're all playing together very well. Bit of context around Trusted Firmware-M. It's the reference implementation of the platform security architecture. PSA was a program that ARM launched towards the late end of 2017 as a framework to build secure connected devices. It takes a phased approach, starting with threat modeling and security analysis of the actual device you want to build. The aim is to come up with a set of security requirement based on your use case. And the next phase is to put this analysis into action. ARM has produced a bunch of firmware and hardware specification, basically telling SoC vendors how do you build your hardware in a secure manner. And it also creates a contract through a firmware specification as to how the firmware and the hardware should interact, so you keep the security principles that PSA defines intact. But we all know specs are not good enough in a security context because security is a complex problem. We don't have enough security experts in the industry. So as part of the PSA program, it was thought that you should have a high quality reference implementation of the PSA specification, and that's how TFM was born under trustedfirmware.org, basically implementing the specification that PSA defines, addressing some of the threats that is commonly found in some of the IoT use cases. So that's the bigger picture of PSA and how TFM fits in the PSA program. I want to talk a bit about what are the sort of features that we have in TFM today. So fundamentally, if you look at TFM, it is a secure processing environment for Armv8.4 based cores or dual CPU solutions. For V8M, of course, it highly leverages the trust zone technology that is present in V8M to provide a system level isolation between your highly valuable secure code and data from the non-secure world. It's also possible to implement TFM in a dual core solution where one core runs TFM, it's a secure core, and the other core runs your operating system along with its application. So basically, if you imagine this being a V8M core, your right-hand side will be running TFM and your non-secure side will be running your application and the operating system. So how I've listed down the feature is, so PSA also comes with its certification program, and recently we have been working on features that's required for the level 2 certification. And if you look at the level 2 protection profile, it requires you to implement a set of security functions very similar to a common criteria protection profile. So let's go through the security function and see how that's getting implemented in TFM. So one of the fundamental requirements, of course, is to have a secure initialization process where the authenticity and integrity of all the software that's running on the system is validated so that no raw code gets deployed on the platform from an unknown source. Similarly, if the system is going through a firmware update, it should be possible to check the integrity and authenticity of that update, so there is no threat by a update abuse coming from a unknown source or trying to deploy an old piece of software. This is achieved through the secure boot that is in TFM. It's based on the open source MCU boot project, which is forked for pursuing the TFM specification in the last few months. So now it supports several features like rollback protection. It's possible to deploy secure and non-secure images separately, and it basically ensures that the integrity and authenticity of the non-secure and the secure firmware is done before it's deployed on the platform. The next functional requirement for level 2 is to have isolation. So this is again to mitigate against the threat of getting your most privileged trusted software being tampered by any other software that's running on the system. So PSA basically defines three levels of isolation, sorry. The first level, which is called level 1 isolation, is to separate the non-secure from the secure, which is basically done through trust zone. The next level of isolation is inside the secure world, you can have a level of isolation that separates out your root of trust or the kernel of TFM from rest of the software in the secure side, which is called level 2 isolation. That is required for level 2 certification as well. The highest level of isolation is level 3, where your secure services can be sandboxed, so they don't have to trust each other. So we today in TFM supports up to level 2 isolation. In terms of services, it's required that you should have a secure storage service in place, which is basically to ensure the confidentiality and integrity of all the highly valuable secrets in your system. So TFM, as per the PSA specification, implements a storage service. There are two types. One is protected storage, which is to basically store high data sets in, say, an external flash once it's encrypted. And then there is the internal trusted storage, which is something you would store in the embedded flash. And there are a set of APIs that's defined for storage. The next requirement for level 2 is to have a crypto service, again to mitigate against having weak cryptographic support on your platform by having weak algorithms or the wrong key sizes. For that, TFM leverages the Embed Crypto project, which is a relatively new project, a derivative of the Embed TLS project, where there are a set of algorithms which has been taken from the original Embed Crypto project, which is available to the non-secure applications, again, through a set of PSA crypto APIs. And it's also possible to interface that crypto service to a crypto accelerator that's available on the platform. The next service is attestation, again, an important aspect in the connected world. So using the attestation service, it's possible for an application to prove its identity to a relying party. Suppose I've got a sensor which I want to connect to a cloud provider. It should be able to say that, okay, I am device X and Y, and it should be possible for the cloud provider, which is the relying party, to say that, okay, this is a genuine device, I can allow it to be connected. So the attestation service in TFM allows that to happen. And again, we leverage a specification called EAT, Entity Attestation Token, which basically takes a set of device-specific data, encapsulates it into a token, which is defined by the EAT standard, which is contained in a CBOR container, and it is signed using an attestation key, which is unique to the device. The private key will be part of the platform, so the token will be signed using that private key, and the public key will be available for the relying party to unencrypt it and prove that the tokens has got the expected values. Secure audit, it's another service. So this is a service where every other secure service can log all the security events that's happening on your system, so that in case there is a breach, it's possible to go back to the system and identify what were the security events, which were the actors who tried to access the different systems on the platform. Secure state, it's all about maintaining operational state of the device, even if there is a attempt to bring down the system. the valuable assets in the systems are not exposed. So there is enough checks in place in TFM to make sure that's available. So then there is in TFM a HAL layer which makes it easier for platforms to take the TFM code base and quite easily port it to their own platform. And there is quite a neat abstraction at the HAL layer for that. And again, each of these services, as you can see, has got a set of PSA-defined APIs. So the whole idea is if you have got applications running on top of the RTOS, it should be possible to use those PSA APIs to get secure services, whether it is about storing a valuable asset or encrypting a data you want to send it back to the cloud or getting the attestation service or audit logging. It's all exposed through a standard set of APIs. And the whole idea is when the application moves from one platform to another, if it's a PSA-enabled device, you should be able to get these secure services through those PSA-defined APIs. So this is an overview of what we support in terms of feature set today in TFM. Now, let's look at some of the other things that has been happening in tf.org related to TFM. So as Matthew was mentioning, one of the important things in a community project is your testing shouldn't be opaque to all the contributors. It should be possible to submit a patch to the Trusted Firmware M or A project. Then you should be able to see what does my regression test run results look like. So as part of that, TrustedFirmware.org has made an investment in an open CI system, which is today hosted in the Linaro infrastructure, which makes it possible to have the CI system out in the open. So if you go to ci.trustedfirmware.org, you can see the testing happening in live, and it's open to everyone. So what basically happens, just like any other CI system, any TFM patch that gets submitted into the Gerrit would trigger a TFM build in Jenkins. It would create a bunch of TFM builds in different configurations. And then that would shoot off a test campaign into the Lava system, which is the Linaro validation system, into the Linaro servers. And there are platforms which are attached to the Lava system, which would take those builds, run the regression test, and send back the results to Jenkins, which would, if all the tests are passing, would give a +1 in Gerrit. So it's just like any other CI system, as you would imagine, but the important thing is it's out there in the open. TrustedFirmware.org members over time would be adding their own platforms. The advantage there is they can make sure any TFM patches which is getting added to the code base doesn't break on their platform. It still runs, so it has that benefit of making sure that platforms are always up and running with the latest TFM code base. And what's coming soon is we are in the process of working with Linaro to have a similar system for TFA as well. So it should be possible for every TFA patch also to be tested with different A-class platform. The starting point would be adding the Juno platform, but that will be followed by FVPs and partner platforms, hopefully in the CI system. So again, a big value add of being part of this open collaborative working model. So moving on from the test system, it's quite important for any such project that you should have enough platforms to work on with. So when we started off the TFM journey 18 months back, one of the primary platforms used was the ARM IoT reference platform, Musca A and Musca B. That always has been supported in the TFM project. We had a reference MPS2 platform, very much similar to Musca, but it was not actual silicon, it was a FPGA platform. But since the last connect, we have got a few more platforms from the ARM silicon ecosystem. For example, the NXP LPC5569 platform. So the NXP MCU Expresso SDK now includes a build of TFM. So if you've got an LPC board, you take the SDK, it has got the TFM code base, it's possible to run that. So it gives yet another platform that you can start your journey towards running applications leveraging TFM. On the TrustedFirmware.org project, there is another platform, which is a Cypress PSOC6 platform, which is also supported, which runs TFM. It's interesting in the fact that Musca A, this FPGA platform and the NXP platform, they're all M33 based, so it is trust zone enabled, whereas PSOC 6 is a dual CPU solution that has got an M4 and an M0 plus. So the M0 processor runs TFM and the M4 runs non-secure OS. It can be Mbed or Sapphire or FreeRTOS of your choice. We have got a few more platforms that will be supported in TFM in the coming months, but one of the interesting ones would be a model where, as part of the ARM Design Start program, today there is a FPGA platform which you can access in the Amazon marketplace for like $1.65 an hour. So it's possible to log into that system. As part of the TFM upstream work, we are going to support that platform. So even if you don't have a silicon platform or an FPGA platform, you should be able to go through the Amazon marketplace, log into the system, and run TFM. And the good thing about this platform is it's possible to use it as a hardware and a software development environment, because you can add peripherals to this FPGA platform, then you can run TFM or other software. So it's a good development platform, and it's mainly aimed towards academics and startups who doesn't have silicon platforms or FPGA platforms to kickstart their development cycle. So that's more or less about the TFM-enabled platforms. Then the other thing that has been happening in the TFM project is integration with different real-time operating systems, because TFM on its own doesn't add much of a value. It has to be integrated to the different embedded ecosystems so that applications can leverage that. So if you look at the TFM diagram, you've got TFM on the right-hand side, you've got RTOS on the left-hand side. So TFM is a bare metal solution. You can have any RTOS as your non-secure counterpart. So as part of integrating the different RTOSes, so EmbedOS is something which has been supported for the last several months. Since the 5.12 release, TFM is part of the releases. There are several PSA certified devices in the EmbedOS repository which has got TFM running. Sapphire, again, we have been working with the Linaro Lite group to integrate TFM into Sapphire. There has been some really good progress. So the Musca and the FPGA platforms are now integrated into the Sapphire code base, and we'll soon be getting TFM also in the Sapphire code base. We are also working with the FreeRTOS team in Amazon, going through an evaluation of integrating FreeRTOS and TFM, and there is also work happening in terms of investigating how best TFM can integrate with Amazon FreeRTOS. And recently we kickstarted work with another Chinese open source RTOS called RT-Thread to see how we can integrate into their ecosystem as well. So these are the current real-time operating systems that the project is trying to integrate with, again, to make it part of the IoT embedded ecosystem. So we just covered the features, the test system, the different RTOSes that we have been working on. Now let's look at what are the other things that's going to happen in the next few weeks or the next quarter. So as I said in the beginning, TFM has been working towards enabling platforms to be level 2 certified. As part of that, we have been going through a evaluation with Riscure to look at the TFM code base as to how it fares against the PSA level 2 requirements. We have got some observations, and we are in the process of fixing those comments or observations from Riscure and aiming to produce a next release candidate by middle of next month. And this is again to enable partner platforms who have a desire to get their platforms level 2 certified. They can take the TFM code base from trustedfirmware.org, port it onto their platform, and submit it to one of the PSA labs for level 2 certification. So that's one of the major activities that's happening in the community project. Then the other integration that is ongoing is the crypto hardware work. So it's quite common in all these platforms that there will be some sort of crypto accelerator. So it's essential that TFM integrates with those crypto accelerators to leverage the hardware unique key and the crypto acceleration that the platform provides. So we are in the process of integrating TFM with the crypto accelerator that's present in the Muscabee platform. What that would mean is, for example, the secure boot would leverage that crypto accelerator to have its public key for the images stored in the OTP of the crypto accelerator. If you look at the runtime crypto service, if there is a call from the application, it wouldn't do everything in software. It would route those calls into the crypto accelerator so that you get more performance on your platform, because it's all being done in hardware rather than in software. If you look at secure storage, again, it works with the crypto service then to make use of the crypto cell, so you can derive the keys that you need for encrypting your assets from the crypto cell. So the crypto cell is possible to have a key derived from the hardware unique key. So that's also something that is quite commonly used mechanism in the space. Attestation, similarly, it can use the attestation key which is stored in the OTP of the crypto cell. So again, the aim here is to show some reference implementation as to how TFM would integrate with the crypto accelerator. And depending on the platform you have, you might have different crypto accelerator, but this is a starting point to show how TFM as a secure software would integrate through standard interfaces to crypto accelerators. So that was more or less what's coming up in the short term. So just a quick look at the roadmap. So today we support a set of PSA APIs, the 3 services. It supports level 1 and level 2 isolation. Over the next few months, we'll be enabling a lot of platforms to get the PSA level 2 certification, moving the implementation to the latest PSA specification, but because we are trying to be sort of at the same level as how the PSA specifications are progressing. Then early next year, we'll be in a position to show how TFM can integrate with different crypto accelerators, then have the higher levels of isolation. We might want to have different TFM profiles because we are talking about very constrained platforms. So the memory footprint might be like, okay, there can be a platform which has got 2 MB of flash, or it can be a device which has got 128K of flash. So we want to have different configuration of TFM that would fit into these different configuration of devices. And in the longer term, there are plans to have even more secure services like provisioning, secure debug, platform-based services, so that applications can leverage those to make their device even more secure. Something on the collaboration front, just to let you know, we are all getting together as a TFM developer community in Lyon towards the end of October for a 2-day workshop. So that's going to be a forum where the ARM, Linaro, and a lot of silicon vendors and RTOS vendors are going to get together and discuss some of the interesting issues around TFM as well. It so happens it's the date when Brexit is supposed to happen, but hope everyone gets back home safe. It was not a planned thing, it just so happened. The next thing is we are also going to be present at ELC Lyon. So trustedfirmware.org is a sponsor. So we will be running a booth with some TFA, TFM demos again in the last week of October. So if you're around, please do turn up. We can have more conversations around some of the Trusted Firmware activities. So as Matteo was saying in the beginning, just wanted to have a few words around how you can get involved in the project. So if you look at, if you sort of step back and look at the whole mission of trustedfirmware.org, it's all around building security in a collaborative fashion. What does that mean? So it's about having a shared ownership of the code base rather than a code base which ARM owns and runs or Linaro owns and runs. So this whole endeavor is to have a common code base that a lot of people in the ARM ecosystem can use. What that would mean is security is a complex problem, and by solving some of the complex security problems in some of this common firmware code bases, it's possible that you're solving the complexity in one place. And that's the only way we think security is going to scale. So if you think of the Spectre meltdown days, it was quite possible that you fix some of the vulnerabilities in kernel and in some of the firmware project, and you could immediately deploy it in a lot of devices quite quickly because they were all based on Linux kernel and some open source firmware implementation. And even from a market standpoint, once you use the open source firmware implementation, it's always possible that your cost of deployment, maintenance, everything massively comes down because you're getting all the goodness, the vulnerability fixes all from this open source common code base as well. And it always reduces your time to market as well. So on a day-to-day basis, there are quite easy ways to get involved. Of course, there's no restrictions to making code contributions to Trusted Firmware-M or Trusted Firmware-A or Opti. You can raise a request to the patch system using Fabricator ticket. There are some good mailing lists which you can find from trustedfirmware.org where some of the good design discussions happen. There are Linux kernel-like discussions as to why some design is good compared to others. So if you're interested in those sort of discussions, please do join the mailing list. Again, there's no restrictions of being a member or not to join the mailing list or make code contributions. But if you want to be part of the strategic direction and the technical direction of the project, please do consider joining the project. As Matteo was saying, there is a few members today who's actively contributing into the future direction of both these projects and from now on Opti as well. And you get a seat in the board. You get to have a say on how we want to run this project going forward, and there's a lot of benefit in you also being part of that journey. So I think that's all what we wanted to say. Again, we'd like to welcome Opti as a project into the trustedfirmware.org project. So I think Opti will even attain greater heights by being part of this trustedfirmware.org endeavor. And this time around, we were trying hard to find a reason to get some cakes and wines because it has become a tradition in the last two connects that I think in Vancouver, it was the 5th birthday of TFA, so we could arrange a party for that. Last time it was the 1st birthday for TFM. Now there's a lot of interesting stuff happening in the project, but we couldn't find a birthday today. So taking this opportunity to invite everyone for the next Connect, where we are going to celebrate the 2nd birthday of Trusted Firmware-M. Thank you.